Welcome everybody. In this video today we will discuss the logic gates, the concept of logic gates. Okay. So what are the logic gates we have? The basic logic gates are NOT gate, OR gate and AND gates. These are the three basic gates. These are called basic logic gates. Okay. Then we have NOR gate and NAND gate. These two are called universal logic gates. Okay. So five gates are there. Three gates are the basic gates, NOT gate, OR gate and AND gate, and two gates are universal gates like NOR gate and OR gate. Sorry, NOR gate and NAND gate. Fine. Now we will discuss one by one what are the basic concept of all these gates. These are basically electronic circuits. Gates are nothing but electronic circuits which are having certain inputs, and depending on the inputs we have some outputs for all these gates. Okay. So first we discuss NOT gate. NOT gate. So we are discussing NOT gate. The logic diagram of this NOT gate is like this. Okay. This is called input and this is the output of the gate. Before NOT gate, we must know the concept of buffer. So the concept of buffer is like this. Sorry, there is no circle is here. It is called buffer. Buffer means it will give the input as the output. That means if you give 1 as the input, you will get 1 as the output. If you give 0 as the input, you will get 0 as the output. So whatever the input is, the output is the same. So basically it holds that bit for some time, or it is a temporary storage device you can think of. Here we are putting one circle after the triangle or arrow shape, which is depicting the not functioning. And what is not? Not means negation. And what is negation? Negation means whatever the input is, it will be converted to the or inverted to the bit which is depicted as negate or negativity. Like if 0 is the input, it will be converted into 1 as the output. If 1 is the input, it will be converted as the 0 as output. So input is 1 if the input is 1, the output will be 0, and if the input is 0, the output will be 1. Okay, now we will go and look how the truth table look like. Okay, truth table for NOT gate. Truth table. So here is 1 bit input and 1 bit output. Either you can put 0 or 1 at the input, you will get 0 or 1 at the output. So like that we have input and output. So if you are putting 0 as the input, you will get what? 1 as the output. If you put 1 as the input, you will get what? 0 as the output. So this is the truth table for NOT gate. Okay. Okay, for NOR gate. Now we are discussing. Sorry, we have already discussed NOT gate. Now we will discuss OR gate. OR gate. What is the circuit diagram for OR gate? Is like this. OR gate has two inputs. Okay, so this is a arrow shaped, almost arrow shaped diagram. Is it? These are the two inputs and this is the one output. So if we say A and B are the two inputs, then the output will be A plus B. Okay, so if input is A and B, the output will be A plus B. Okay, now what will be the truth table for OR gate? Truth table for OR gate is A and B as the input, there will be output. Suppose Y is the output, Y equals to A plus B. Okay, now we can have four combination with these two bits, that is 0 0 0 1 1 0 1 1. Okay, whereas if we put 0 and 0 at A and B, what will be the output? The output will be 0. A plus B will be 0 plus 0 equals to 0. We will follow the Boolean algebra here. We will discuss later the Boolean algebra in detail. So the output is here 0. Okay. If we put 0 and 1, 0 at A and B is 1, then what is the output? The output will be 1. So output will be 1. If we put 1 and 0, 1 and 0, the output again will be 1. If we put 1 and 1, then the output will be 1. Okay, here we can see that once we have a 1 in the input section, we will have output as 1. Okay, if we have 0 0 in the input section, that means A and B both are 0, then only we will get 0 at the output section, which is Y equals to A plus B. That means Y equals to A plus B equals to 0 plus 0 equals to 0. So only this case 0 plus 0 gives us 0 as the output. Otherwise we have 0 1 1 0 and 1 1, all are having 1 as the output. That means a plus b gives us output as 1. So this is NOT gate, OR gate. Now we will discuss AND gate. AND gate, okay. AND gate, the circuit is like D. It has two inputs also and output one output here. So A and B, two inputs are there. Y equals to A into B here. Okay, so it's multiplying A and B basically, and gets are there. So Boolean multiplication is also here. So the truth table for AND gate A and B. Again we have Y equals to A into B. Okay, so here again we have four combinations: 0 0, 0 1, 1 0, and 1 1. Now 0 0, if the input is 0 and 0, you will get 0 into 0, the output will be 0. Once we will get a 0, the output will be 0. That means 0 into 1 for the second case, it will be 0. Again 1 into 0, it will be 0. 1 into 1 only gives you output 1. Okay. So this is the truth table for NOT gate, OR gate, and AND gate. Okay. So I think up to this it is very much clear. We will discuss the OR gate and NAND gate in the next video. Okay. So these are the concept of basic gates. We will discuss the universal gate in the next video. Thank you for watching.